Well, glad you made it again here for another episode of Stay Curious. I'm your host, Mark Marquette. Beside me is, of course, our great friend Terry White.
How you
Terry,
doing?
how are you, buddy?
Good.
Good. He was chief of the shuttle program orbiters for not your whole career, but you spent the whole shuttle era working on it, Terry. And we're so glad you're here today. How are you?
I'm doing okay. Yep.
I'm getting wound up here. And we advertise questions for Terry, and we want you to indeed do that. I've been running around here with my chicken with the head cut off, doing a lot of good things today for our Shuttle Fest in June, and I'll reveal all of that tomorrow. But today, Terry was going to also talk a little bit about the RCS, reaction
RCC. No,
uh,
RCC.
RCC.
Yeah, the reinforced carbon. The
Oh, the
nose.
RCC. I
The
thought it was
nose.
reaction
The
control
nose.
thrusters.
Yeah.
Okay.
No. The nose cone and the leading edge of the wing is the predominant reinforced carbon.
Well, that's why we've done almost 1,500 episodes, and none of them ever scripted to the T. And
Yep.
but Terry was here in the building for our Shuttle Fest meeting and agreed to come in today, Thursday, and we didn't touch base about what you wanted to talk about today. But oh yeah, the tip of the nose of the shuttle, we need to paint that uh, uh, gray
Yep.
because I talked to the guy that polished it for weeks. They actually their job was to keep polishing it like you'd grind a mirror
Yeah.
to get the profile that you wanted on that. So we're here today. Y'all familiar with Terry? Those of the that aren't, just put his name into the magnifying glass there and search our YouTube channel, and you'll find some other fascinating programs there that Terry's done today. And I'm sure this one will be just as fascinating. You've got some questions, throw them out there, Marty. If Marty and I'll be looking for them, but yeah, give you the floor here. Let's put that orbiter over here a little bit. Got me some frizzy here. So frizzy, what's frizzy? And I'm going to move our picture over here. I moved it away, and I want to.
FRISI is the acronym for Felt Reusable Surface Insulation. So it's a Nomex felt with elastomer coating. It's for areas that see less than 700 degrees.
And this is two layered, like a sandwich.
Yes, it is. Yep.
Are there one layered, three
Yep.
layered?
There are one layered and three layered. Yeah, multi-layered depending on where it's at on the orbiter.
What's the difference of this than the blanket?
The blankets, they withstand up to 1200 degrees, and they're actually made from silica sand like the tiles are. And then they have a different fabric on the outside. So depending on how much heat they're going to see, like if we look at this area right here.
Let's put
Well,
this on there.
yeah,
There
on
you go.
on the leading edge. I mean, here we can see the reinforced carbon, the gray material right here that does see 3000 degrees on re-entry. Then right behind it is a row of the high temperature tile to see up to 2300 degrees. And then you have blankets adjacent to that to see up to 1200 degrees. And then the frizzy out here that is less than 700 degrees. So there along the leading edge of the wing, in a span of 24 inches, you go from 3000 degrees down to less than 700 degrees. So the original designers were very accurate about predicting what temperatures they were going to see.
That's what I was going to say. Were the models before the shuttle flew pretty accurate? And you just
They
said they
were.
were.
There were a few areas that we had to go modify them after some flights.
One was the eyes of the OM's pods, right?
Yep, yep,
That was getting too hot, so
yeah,
you got
yeah.
some black, some
Which
darker tiles.
went from the
You
white
taught me
tile,
that, and
and we changed them to the black tile, which withstand more temperature, and it solved that problem because rotate a little bit right inside the ohms pods. There are the fuel and oxidizer tank for the thrusters on the pod, and that area was getting too hot. And you definitely don't want the fuel to get hot. So
there you go. Looking around here for some things I got here. Um, no, love everybody watching today. We've got my daughter Jessie and my granddaughters McKinley and Macy watching today. I bet you have a family member or two watching
supposed
today.
to, yep.
Doug Force is in California taking a lunch break. Thanks, buddy. We posted Doug's picture with astronaut Jim Adamson. Jot your picture, your sketch of the Endeavor front of it there that we'll show tomorrow on our show. Um, And Jim McDade says, I polish my nose before taking off every morning on there. So good to see Jim McDade. Did you ever meet Jim?
I don't think so.
Jim's a real
Doesn't.
space
Yep.
hound out there from the 60s, and he's at in Huntsville,
Okay.
Alabama there. And there, Tommy UCX says hi to you. And Dave Stangy says, a cool green screen today, gang. And that is one of my favorite shuttle era pictures. That's 67 of a flight flown in the month of March. And what are we looking at there, Terry?
We're looking at the heat effects of a re-entry of a vehicle. You can see how it's making it glow around the vertical stabilizer and the orbiter maneuvering system.
We don't have any slides today, gang. Didn't load one up. Didn't want to. Just wanted to kind of, Terry and I just, like I said, field some of your questions. He wants
Okay.
to talk about the RCC. Of course, that become very well known when on the left side here, a piece of bipod foam hit the orbiter about right there, busted a hole through that RCC that they were surprised that it busted it so much. There we go. We'll do it old school wise here. What were we looking at there, Terry? Let's get the orientation right. Okay.
Your
Pieces of reinforced carbon, including a panel removed from the wing of Space Shuttle Atlantis, showing brittle failure.
Yeah, that was our test in the end. We here at Kennedy Space Center determined that's what happened, but we had to prove it. So that is the proof right there. That's where a piece of foam hit the reinforced carbon panel and it knocked a very large hole through it. And that's what had happened to Columbia. Then it got inside the reinforced carbon, then inside the wing, and it was literally melting the wing from the inside out.
Wow. And of course, that was detected first as it came over the coast of America, really. Like about New
Yeah,
Mexico's, where there were some photos taken that showed the glow.
of it shedding parts. Yes.
But what did Rick Husband and the pilot know?
They had no indication. They cannot see that area from inside the orbiter.
But they saw sensors going offline.
Yes, but that still didn't tell them that they penetrated that. And the experts,
What sensors would they saw gone offline that I referred to
yeah,
here?
the ones in the wheel well.
Yeah.
Yeah, there weren't sensors inside the wing right there. After the Columbia incident, then we put sensors inside there. But yeah, they were in the wheel well, and the experts had determined that they thought it had hit the underside of the wing, and we would have a lot of tile damage back there and possibly some structure damage, but they did not think it affected the leading edge itself.
Oh, so
Marty's got a
yeah,
question.
Marty's got a question there. Jump in there, Marty.
Here we have two questions. One from Dave Stangy. Was there a specific tile or area that needed to have tiles replaced on the orbiter? And he meant because of the heating and use, they need to be replaced.
Well, there were some areas that we had to remove several hundred tiles and make thicker tiles to put on there to satisfy the margin of safety that we needed. But there was not specific tiles that we had to replace every flight. We replaced them based on the amount of damage they had received, or some of them we took off to evaluate the structure underneath. We took them off to look for hydraulic fluid leaks. There's all kinds of reasons we took them off, but there was no set tiles that had to come off after every flight. But things like the antennas are underneath the tiles. So if we had to replace an antenna, we had to remove all of the tiles that were covering that antenna.
And we need Steve Jokem's spaceport Lake County spaceport to decal this bottom of this here. That's what Steve does. Please check them out at Lake County Spaceport for all your decal shuttle needs and other model accessories. And I see that RG Jubilee's got a question there, Marty.
Yeah, we have two more questions. Yeah, RG Jubilee is asking, is there a space shuttle model or a kit that you could buy and make, or is it especially made for the museum?
Yes, it is a kit. This is the 4D Vision kit, vehicle cutaway model. I believe it's it might be $150. It's not a very inexpensive one, but it's very good. And I thank our model maker, Dan, who working for us through AARP. We don't hire a model maker. But he fixed it up, Marty, and all the people are where they belong, and nobody's rattling around in there. Okay, so he's really fixed that up for us there, and brought the landing gear down. But it is your comment on the accuracy of this little model
It
here.
looks fairly accurate, yes.
You've got the cutaway to show you the tanks and so forth. These yellow tanks there, those were some things that survived the Columbia reentry, correct?
Yes.
In there in there. So thank you, Rosalie, for that question there.
I've got a question from Jim McDade.
Uh-huh.
What is the max temperature on the cargo bay doors during re-entry?
The maximum temperature up there, well, it's got to be less than 700 degrees because a lot of the payload bay doors are covered with frizzy. But remember, the angle that the orbiter comes in is like this, so the upper surface is relatively cool. So
Excellent. Oh, I do see what's not on here. Someone's got another question. Something that's not on this model that we need to find.
where's the body flap?
Where's the body flap? All right.
It's the only aircraft type vehicle in the world that I'm aware of that has that additional aero surface in the center of
There's
the
supposed to be a
fuselage.
flap hanging out.
There's a
down
body
here.
flap there.
Okay.
So it's used on ascent and reentry. So
And the one you see on Atlantis at the wonderful Atlantis building.
is actually originally started on Challenger. So there was an issue which I'll explain in another show, but we swapped body flaps from Atlantis to Challenger, and we were going to swap them back at a future date, and then we lost the Challenger, so they never swapped back. So
I think Dan's making a body flap for that. He was
Okay.
looking into that, but it's got the hooks there for it. But was the everybody knows this is more like a conventional airplane look with the rudder.
but it's
would be
the rudders are also speed brakes.
speed brakes
They
right there.
flare out,
that
yes.
open up
Yep.
in there. But what's the body flap do? If we had this flap, actually, there it would look like that right
Yep.
there.
Yep. So
Yeah.
so it's used to control the fifth aero surface to control the vehicle. It's important on re-entry in that it helps slow the orbiter down
Shoot, we
when
may
it
be
comes
using-
back. But yeah,
might
so
be
the
able to-
body flap is used on ascent and on re-entry.
right there. So
Yep.
I love looking at it on Atlantis and thinking, I'm so happy there's a piece of Challenger in this building. I think
Yep.
that's cool. Yes, Marty.
Question from Tom Usiak. How much damage did you find to the body flap from the overpressure at SRB ignition on STS-1?
I don't recall the amount of damage, and post SDS-1, I was a supervisor in the forward, so I wasn't responsible for the body flap. But we had a lot of damage all around the engines, the base heat shield, the upper body flap, and all that from the igniters. Right before launch, you see all these sparks flying across the aft of the vehicle, and they're burning off any residual hydrogen that may be back there, so we don't have an explosion. And they literally look like you shot the tiles with a shotgun. So we came up with a method to repair them without replacing them, because it's a hard area to bond a bunch of tiles because the engine's being pulled out as soon as we can, and you have to have everything put back together before you put the tiles on it. But let me explain a couple things about the reinforced carbon-carbon.
We're again
Well,
talking about the leading edge
Yeah,
here
yeah.
and
So-
the very nose.
Yep. So yeah, the reinforced carbon-carbon, they are the portions of the orbiter that see the highest heat. RCC was originally used to protect the intercontinental ballistic missile nose cones. Okay, to be used on the orbiter, it had to be reusable, lightweight, and low cost. RCC was reusable, but it was not lightweight or cheap, but it could handle the 3,000 degree Fahrenheit temperatures. It could be manufactured to conform to the shape necessary for the nose cap and for the leading edge of the wing. For the curvature, it curved in multiple directions in that. So it could be fabricated to do that. It had to be smooth aerodynamic loading while protecting the underlying structure. Loading included launch acoustics, sound from the engines and the boosters, associated structure deflection. Remember, this is like an aircraft. It flexes, expands, and contracts on orbit temperatures and the natural environment. So the RCCs and the rest of the TPS had to satisfy all of those conditions. Initially, only the nose cap and the leading edge of the wing were reinforced carbon-carbon. Then we discovered an issue with the forward ET attach point, That's where the external tank attaches to the orbiter, right underneath, just at the behind the nose landing gear door. Uh, that separates with an explosive charge, and the shock of ET separations was breaking the tiles during separation.
Ooh.
The tiles were replaced by 2 thin RCC plates and a home plate or arrowhead blanket underneath the plate. Okay, we had to cast a mold of each of the orbiters before we ever took the tiles off, so that the contractor could build the exact part for each orbiter. Takes a long time to manufacture reinforced carbon because of all of the firing processes required. RCC is expensive. We used to refer to it as Jed Clampett money. For any of you that remember the Beverly Hillbillies, when they were, he said he was getting paid for his oil in some newfangled kind of money, some million dollars. But yes, RCC takes months to build, and it costs millions of dollars for each panel.
Each piece along the edge was what? You're gonna get to that, the
Y- y-
dimensions of them.
No, I don't have the dimensions. I don't even have the weight. But yeah, so there's 22 for each wing, and then between each of the 22 panels is what we call the T seal. There's a panel that you can see it on here if you want to point it out to them. Those are the big panels, but then there's a thing to go in between where the two of them join.
So you see
Okay.
two different sizes there, thin and then the longer where the.
Yep.
Oh.
Yep. And RCC was originally built by Volt Corporation of Dallas, Texas. Later, Lockheed got the contract to build the RCC parts. Prior to the first flight, design deficiencies were detected, modifications and manufacturing corrected most of those. One was the gap heating between the reinforced carbon and the tiles that are adjacent to it. The hot gas flow would get through, and retrofitting the hardware on the orbiter, we had to go change the part of that subsystem to account for the substantial increase in that, because the fasteners that hold the RCCs are not bonded onto the ship like the rest of the TPS is. They're mechanically fastened. So there's a structure that we put up there and mount the panels up, and then actually bolt them together. So, but part of this thing was when they came up with the right changing from steel to titanium, it solved the issue, and it resulted in a weight reduction of 300 pounds. So that's everything we strive for, was to make things as light as possible. Okay. During our 30 years of processing, other issues were found during our inspections, problems with the T seals, and resulted in having to modify the manufacturing techniques for them. Pinholes was detected, and it was traced to the work on the launch pad structure. The zinc primer used on the pad reacted to the silicon carbide coating on the RCC, causing pinholes. So the work they did out there to help corrosion protect the launch pad was actually damaging the RCC. We developed repair processes for them. This was not the only work at the pad that caused chemical reactions to the orbiters. Problems like this affected the lifespan of each RCC panel. So we had a predicted lifespan of each panel. It wasn't 100 flights. That's what an orbiter is built for. But depending on where they were on the vehicle, we had to change them out after a certain one. But once we discovered what was causing these things, it helped us reevaluate the RCC panel lifespan. The Columbia incident and subsequent tests, including new procedures in the ArtJect facility, we performed new and more inspections and additional X-rays after the Columbia thing, and installed 44 sensors, accelerometers in the wings to detect impacts. So that's one of the instruments that was never there till we had the Columbia incident.
44, like 22 on each wing, or
Yeah. And on orbit damage in sections were performed using the boom. Okay, after the Columbia incident, then we started flying the boom along with the arm, and so they would use them to go inspect the orbiter. They could now go look underneath, what they never could prior to installing the boom. So we did 100% photography of the outside of the orbiter before flight. Once they got into orbit, they did it again 100%, and they would send them back, and we would have people sitting here evaluating pre-flight and post liftoff photos to find out if there were any damages. And if we found some, then we would have to satisfy the community that it was all right to continue what it is, or we would have to go do an evaluation by building the same exact problem they had up there, like they did in Apollo 13, and then go out there and come up with a solution. And we did that in a very short period of time because we couldn't give them the okay to come home until we satisfied that requirement. Okay. Also, the orbiter would perform a backflip maneuver when arriving at station if it was a station mission, and astronauts on ISS would take photos. All of this photographic was relayed back to Earth for us to compare it to. And not only did we take them in the OPF when we were done, we took additional photos in the VAB and at the pad of all the areas accessible. So we had the latest photographs of the orbiter. The RCC is designed to withstand high heat and maintain its shape. The material has a relatively high thermal conductivity, so it did not significantly inhibit heat flow to reach the orbiter's skin or metallic tiles. So the tiles absorbed the heat, the RCC did not. That is seen when a portion of tile material can be removed from a 2,000-degree oven and, while it's still glowing, picked up with your bare hands and it doesn't burn you. You cannot touch a hot piece of RCC. It's like reaching into a burning fire and grabbing huge hot embers out with your hand. It's not going to work.
So that compromised on landings, the landing crew, how close they could get to the wings they had. That's why you see them kind of go around.
And the nose cap, because the orbiter sits in a nose down orientation on the runway. But initially, we have crews that go around inspecting for any possible hazard that's leaking out, any gaseous commodity or liquid commodity before anyone can get close to it. We have people all suited up to go evaluate that. Then we put up huge fans cooling the orbiter down, blowing on the orbiter and that before we let anybody get close to it. But the tiles cool down relatively fast, but the nose cap is still hot for a long period of time. And you would see people who had no business being close to it go out there and they reach up like they're going to touch the nose cap. And I would tell them, don't touch it. It will severely burn your hand. Your hand will stick to it and that. I said, and on top of that, you're not allowed to touch the outside of the orbiter, period. So even if it was cool. Okay. And
so how long would it take me to get to the emergency room? Because I would.
There's a canal with big gators out there. We just slide you over into the canal. So,
but everyone, did you ever have a problem with that? Everyone just really took it seriously, right?
The people that worked around it took it seriously. The ones I call the looky-loos, that show up, they would come up there and you'd have to tell them, do not, I said, no. I said, you can tell how hot it is by turning the back of your hand toward it. You can't even get close before you want to pull your hand away. That's
amazing.
Most
something
of the TPS,
invisible things you see on the runway that I love, the gases, the heat.
Most of the TPS on the orbiter is bonded or glued to the structure. All of the reinforced carbon parts are mechanically fastened.
That's interesting.
And that gives you the RCC in a nutshell.
Thank you, Terry. Fascinating. Did the RCC evolve from the beginning of the shuttle on the drawing board?
Yes.
So
When they evaluated what they needed, they looked at what they were using for the ICBMs.
So until 2011, this was 1970s technology.
1960s technology.
Well, they're correct me there. Yeah. And I know we got several questions there, but I wanted to ask my question is in this picture here of the test to prove that something hit the edge there and busted it. Behind there, you may have spoke of it, but behind there was more insulation because I've handled some in my hands here on our other shows.
Yes,
so
but because like I said, it still radiates the heat, so you still need to protect that aluminum structure behind there.
Right, with and it was a frizzy type material, though.
Yes, it is. Yep.
Which where'd I go for frizzy?
It's right there under your hand.
Oh yeah. This is so you were stuffing this behind the RCC or something similar.
Yeah, but there's still a lot of hollow area in there.
Right. So. Yeah. Oh, you could. I've heard stories of people crawling in there. Right.
Not much space, but you're crawling in there to bolt it in place.
Right. Well, always interesting to be here with Terry White, and Terry.
Yeah, here's another view of you can see the hollow behind it.
Oh, there you go. I was going to say, bring some more pictures. There you go. There
you see the red and green. That is the leading edge of the wing structure, the aluminum structure.
All right. As this is the top side, and then that's looking.
Yeah.
Well, I guess I'm looking at it top side.
Yeah.
Let's go from that to this here.
Yep.
So. Yeah, and you got another graphic there to show before we can go get into a bunch of questions.
Well,
right
that's
quick.
just showing how it could take the heat and what the displacement of the air and everything was around the vehicle. Because the vehicle, when it's re-entering, it's pushing a cushion of air in front of the vehicle and out ahead of the vehicle, which you don't want to disrupt that flow of air, or you will get even more heat to the vehicle than you had planned on. So that was
Mhm.
really important. That's called tripping the boundary layer. So
Interesting. It's an astronomy analogy. Is meteors coming in hit that boundary level, and they burst up apart
yes.
because they push so much air in front of them that that air becomes a wall, and meteors break up, and we see them as streaks going through our sky.
Yep.
So great. Marty Winkle's got a bunch of questions for Terry, and we're so glad that you spend your time with us, Terry. Um, Probably be your last show for over a month or so, as you're going to have some be out, we'll say, for personal reasons. And Marty, so get your questions into Terry because we'll miss him, but we're going to put this together with your written program. Excellent explanation, Terry. Go ahead, Marty.
Okay, Rich Rothman is asking, I think you partially answered this question anyway. Were the sensors that were placed in the leading edge of the wings following the Columbia accident temperature sensors? If so, what good would it do to know about the temperature increase in the wing? And here's a follow-up question. What could a crew do, if anything, to remedy a hole in the leading edge of a wing uh, on flight after Columbia?
Well, they did a bunch of different companies assessed ways to do on orbit repairs, and they did develop one that was almost like a group that the astronaut would trial on out there. It would not withstand the repairing the RCC. They looked at the potential of, oh, well, you could just carry a spare RCC panel. There are 22 panels per each wing, and they are not all the same shape. So they vary in thickness and contour and that from the front to the back. And
Yeah, they're
so
curving
yeah,
around
and
the edge
so
surface
when
here.
some of
So
these companies came in and said, "Yeah, we'll just carry spare RCCs," I said, "Then you won't fly because you put all that extra weight in the payload bay, you're not carrying any payload." So basically, the sensors were to let us know if we had some of the same type of issues with Columbia and we had anything in the wing where we would have to go plan for a rescue mission, and that was something we did post Columbia. We always had another orbiter, another shuttle that was within a few weeks of launching to go up there. That's why at first they didn't want to go do the last Hubble repair because there was no way. And most of our missions were going to space station after Columbia. So if there was an issue with the vehicle, they would just put the astronauts on space station, leave them there till we could get a rescue vehicle up to get them. So, but we wanted to know if we were getting any more impacts. That's why they had all the sensors installed on the wings.
You want to address the sensors.
and
He's
were
asking
they?
about were they temperature sensors?
They were both. They were basically acoustical and temperature sensors. So
So in the 20 some flights after Columbia, what did the sensors reveal?
I don't know. That wasn't my part of my.
Oh.
They didn't come back to the floor and tell us what they were seeing. But the astronauts on subsequent visits to Kennedy Space Center, they were interested in looking inside the wing. Now, most of them had never seen inside the wing before, so that was one of the things they would ask is, "Hey, can we go up and look in the wing?" So it granted permission to go up there and look in the wing. So it's not the most comfortable place in the vehicle, but
Claustrophobic. All right,
Okay,
Marty, what else we got from our great viewers today?
got a question from RG Jubilee. If the astronauts knew about the breach and the leading edge, could they have flown a different approach?
no. I asked that question and they had analyzed it and said if they changed the landing profile to overheat the right wing and protect the left wing as long as they could, they said it would not. They couldn't have done it. So the damage, even though they didn't know exactly what it was, but they knew that there was nothing they could do to mission profile that would potentially, you know, save the orbiter in that condition. So they did assess that, and but and the orbiter only peak heats for about 15 minutes, but it's very hot in that 15 minutes.
We hope you're enjoying this conversation with Terry White. We've done it without any racking up any slides. He's had kind of did it old school, some pictures there, and your sister Peggy's watching. Peggy Holbert, good to see you on there today. We've got Gary Gerald, probably got off his tractor. And is it Vidalia onion season yet, Gary? I think it's getting pretty close. And put a big slice of onion there on a nice meatloaf sandwich is what I can't
How
wait to
did the
do.
onions do in the cold spell? Because
Yeah,
my wife's orchard took a beating.
I didn't. I need to call Gary. I meant to, but Ophelia's in France watching today. CT Cubing. Joy says this is an awesome program, and DKS is hard of hearing. Hard to hear y'all speaking. So Marty sees that note there, and if there's any technical thing, he'll
Yeah, but nobody else is commenting on having any difficulty, so it
right.
looks like it's on his side.
Crank it up. Okay. Lynn Feathers, always one of your fans from West by God, Virginia, up there. I'll bet they're getting some crocuses poking up finally up there in West Virginia.
Yeah, I heard they're getting 60 temperatures.
So, yep. Everybody else hearing is fine. It must just be our one viewer there. So hard. So, but Marty, go ahead with another question.
Here you got a question from Amy Collins. What was the objective of the SILTS program flown on Columbia? What was learned?
You know what? I didn't get the results from the SILTS program, but Columbia was the only one retrofitted with a SILTS pod on the very top of the
So
vertical.
talk about what that is.
Yeah,
here.
and we were supposed to remove it and put the original portion of the vertical stabilizer back on there, but the program decided not to go do it. So the SILTS pod was still on Columbia.
So there's two ways you can tell Columbia in a photograph from all the other orbiters because it is different. And Terry,
Yeah.
the Silts pod is up here.
Yeah, but it
It's-
wasn't on all their flights, but yeah, the SILTS pod.
Okay.
Yeah.
But it was, what did it stand for? What was it doing? Was it a camera looking down or other sensors?
I
or-
forget. That's one of the things.
What do you
that
mean
I
you
have to-
forget?
Yeah.
We have you on here not to forget.
Yeah.
Yeah.
34 years. I don't remember everything every day. So
I don't know why I didn't have a camera up there now that every space course the GoPros weren't popular and so forth like that to resistance. But what's the other way that you can tell Columbia?
well, before STS-1, shortly before we left the orbiter processing facility, go to the vehicle assembly building or vertical assembly building, the original designers thought we might have an issue with the upper wing temperature.
I'll show along here.
Yeah, because the wing glove, the thinner portion of the wing up there, gets hot on reentry, and then we're worried about the upper wing being cool and the temperature differential between the upper and lower structure right there. You further back you get, the wing gets thicker. So they had us go paint all the white area on the upper wing, what we call the wing glove, and paint it all with a black high temperature paint. And so the
About right
astronauts,
there.
Young and Crippen, just prior to re-entry, they rolled the orbiter toward the sun to heat up that portion of the upper wing to get it as hot as they could, and so it wouldn't have as much temperature differential. Turns out it wasn't necessary. Columbia had all kinds of instrumentation. It was the only orbiter that was loaded with instrumentation, but it wasn't necessary, so we didn't paint any of the other orbiters.
Steve Joachim says it's the shuttle infrared lee side thermal sensor.
There you go. Yep.
And of course, Steve gets that $2,000 question here on Terry White Jeopardy. Thank you, Stephen. That looks good. But you see the black. In aviation, they call this the chine.
Mm-hmm.
All right. On
Or the wing glove. The chine is forward of that. That's
Okay.
that's the wing
and the
glove.
wing glove. But it's all black in here, and the other orbiters aren't, as is Discovery does not have the black in there. So that's always cool. That's something I learned that's just sort of ingrained in me now is to look for that and other things that you see, little innuendos and launches and stuff reveal what it is on there. So go ahead, Marty.
Yeah, just lost it. Oh, Michael Bruno's asking, would you say the foam problem was basically solved by eliminating the bipod ramp?
No, it wasn't. I was picking foam out of the tiles STS-1, and they never admitted it till we lost Columbia. Then they went back and admitted all the way back to STS-1. The foam was impacting the orbiter. Even though we lost some tiles because of foam impact, they still kept saying, oh, it really wasn't an issue. And then we lost the orbiter. If you go read the Columbia report, they spelled it out all the way back to STS-1. So, yep.
Yeah.
One other thing I forgot to mention is we had the very first rows of tiles behind the nose cap are VO70 399 415 array, and they are 4 inches thick. They see the highest heat of the tiles on the orbiter and that, and we found out after multiple flights that they could not withstand the temperatures right there. We're actually slumping tile, burn all the way down to the structure. It was literally melting the tile, only on the lower surface, underneath.
Oh, underneath.
Yeah,
Okay.
yeah. And so we did go out there again, cast a mold of that area, and we removed the first 2 rows of tile after the nose cap, and they built as a reinforced carbon chin panel.
Oh, the chin. Yes,
Yeah,
we've talked about the chin.
Yep.
Yes.
So that
Yeah,
was
the chin
also
right underneath.
yeah,
there.
that was the last thing we modified to replace tile with reinforced carbon.
Yeah, we've when we talk about the broom crew,
Yep.
you can see the chin up there.
Yeah.
And once again, what's the broom crew? I would need the broom crew right now to close the door.
Yep. And
Right? That was
also here's
people holding brooms with.
here's a little trivia thing that most people don't know. It gets so hot inside the nose cap that we actually have internal tile behind the nose cap to prevent that heat to get into the forward reactionary control system. So there are 8 tiles in a circle inside the nose cap and they are a few of the tiles on the orbiter that don't need to be re-waterproofed after each flight because they're internal.
Inside.
The rain doesn't reach them.
One thing I wanted to point out and have Terry answer the question: when you talk about repairing the tile or replace in orbit or anything like that, remember the aerodynamics. If any repair you have is going to affect the surface and reentry.
Correct.
And remember, Terry's done several shows with us about the famous 114 return to flight, and there was a
2 gap fillers.
Gap fillers were sticking out between the tiles, and I would think, well, what's the problem? They'll burn up on reentry. But the way they burn up and change the aerodynamics, just that little bit of something that was only like this, right? Like a thickness of my badge here.
Thinner than the thickness of your badge.
When it's sticking up could affect a 20-ton spaceship coming back to Earth.
Yeah.
100-ton spaceship,
Yes.
I mean.
Yeah, because it would trip that boundary layer. See, and originally we put gap fillers in there that were room temperature vulcanizing adhesive made the gap fillers. Then they came out with a ceramic one. Well, the RTV gap fillers, if one of them was protruding, it would burn off. Okay. If it was a ceramic one, it wouldn't burn off. So it would actually then trip the boundary layer. And we had a couple of cases where we found that, and it started to heat flow doing this, and it caused a hot spot back on the elevon or way back on the wing. And we traced it to a gap filler up on the forward as what had caused the issue back on the wing. So it was very important on that flight that they go, since they could see it, before they never had the ability to go see it. So Steve Robinson went out and pulled the 2 gap fillers out with his hand.
Yeah.
And gave them to me on the runway. Said, here, these belong to you.
Yeah, we love that. Great. And there was a live view of that whole situation because of the extra addition remote arm there on there. Mostly Park is talking about the trim on there.
Yeah, so. He actually carried a camera out there with him while he was underneath.
No, he did?
Yeah.
Okay. I'll just take to document it all for later. All right, we got, I see another question from Amy Collins.
During STS-41D, paired aboard, the Rainbirds were heavily spraying the aft end of the orbiter. Would this have caused damage?
Good question, Amy. And our friend Charlie Walker was on that. Aboard.
I've never noticed any damage that could relate to the Rainbirds. Again, that's water that's instantly turning to steam from the heat of the engines and that. So no, but the igniters did definitely cause damage.
The Rainbirds look like stovepipes sticking up.
Yeah,
good analogy, around the pad.
Around there. Yeah, and
after a little cover on them, and you see the water spewing out
after STS-1, we had to add more Rainbirds out there.
Where'd they get that name, Rainbirds?
Because
birds sat on them all the time.
No, there is a type of sprinkler that's a Rainbird, and it looks similar to that. It doesn't spray out a spray like this. It sprays out a fan type thing.
Well, I've never owned a home that I need a rainbird in. Okay, I just do the old green water hose and the lazy little sprinkler system
Yeah,
there.
but you're
So
not dumping 300,000 gallons of water real fast.
no, I'm not. I'm not. Or have some fruit groves like you do on there. So good questions there. And we got uh, the PM White 2010 family members. PM White.
Patty, my wife.
Oh, Patty. Okay. Hey, Patty. Hope you're doing well and your whole family in Louisiana doing well down there.
Yeah, they're swimming already
Are they?
in their pool.
All right. All right. Marty, go ahead. We got a couple other good questions there, I see.
Here, Robert Law is asking, were there problems with micrometeorites?
Yes. And we thought that was our biggest damage issue in orbit, and that was the micrometeorites. And I pulled micrometeorites out of tile, that were stuck in the payload bay doors, because the orbiter flies the whole time in space with the doors open. And that, but it turns out we had to worry more about space debris than we did micrometeorites, because a lot of our impacts were caused by space debris. I picked out pieces of uh, titanium, pieces of Inconel, pieces of circuit board that you can identify. It's a chunk of circuit board that was
Yeah, I was going to say,
stu-
you said one of the most common things was pieces of circuit boards from
Yeah.
satellites that
Yep.
exploded
yeah, yeah,
and
or just abandoned in space, and eventually, So-
micrometeorites are sand grain sized
Yep.
meteorites you're talking about, not all of them
yeah.
microscopic.
And there's a website out there where the Air Force tracks all of those things, and they're literally tracking thousands and thousands of space debris, and they only track the stuff that's as large as a grapefruit up to the size of a UPS van.
Mm-hmm. Mm-hmm. Great, great. Well, Marty, any other questions there? Let's see.
Looks like we're caught up right now.
All right, good. Well, we've easily killed 45 minutes here just talking with Terry, and your questions are awesome. Glad that he had an RCC, reinforced carbon carbon. Why did they put the extra carbon on it there? Carbon
Because
squared.
it's a multi-layered fabric, and I guess because of the fact that they keep putting it in the oven over and over again and making it's basically multi layers of carbon. So that's why they call it carbon carbon. It originally starts out as rayon cloth.
Is that right?
Yeah.
Okay.
Starts out as a cloth, and then they keep
You can
adding
Google
to it.
pictures of workers around it. We've talked about this before and had shown pictures of it. It's like you said, it's sectional is in there and actually bolted into the
There's
frame of the.
some very good photos out there, but most of them, when you go look at it, if you want a copy of the photo, you have to pay to get it. So I don't have access to the NASA archives anymore to look at all the photographs we took. So initially, we weren't even allowed to have cameras around. The Pan Am was the designated photographer, and when you needed a closeout photo, when you're fixing to put on a door or complete anything, then the Pan Am photographer would come up there and photograph it. So after that, we had a picture to go look at in case there was a question about something. We could go look at it. But
See, in my life, I never thought about a career like that. That there'd be a photographer constantly photographing everything in there, or I would have stopped chasing ambulances and fire trucks,
Yeah.
in my Associated Press career there, or going to Madison Square Garden this Saturday. That was the crummy assignment, was Saturday night wrestling at Madison Square Garden. Okay, but somebody had to do it for the international wrestling crowd back in the day. So,
but we had round the clock photographers available. Anytime we were working, there was a photographer there in case we needed it.
Marty, I see a couple good questions.
Yeah, Lynn Feather's asking, is Artemis still launching tomorrow?
Yeah, I've got it on my calendar over there, Lynn. That's going to launch tomorrow at 8:29 tomorrow night. Yeah, good one, you little facetious. You were there.
Unless they're going to launch it right through the roof of the VAD, I don't think so.
We'll talk about that. I see you got another question or two there, but Marty, we'll go ahead with Tommy's.
Tom
Then we
Usiak.
want to talk about some current events.
Tom Usiak is asking, was the engine that had a problem during the STS-93 launch repaired or retired?
I don't know. If we remove the engine, then I don't know. It goes to the engine shop and they determine what to do. I mean, there's over 50,000 parts make up one SME, shuttle main engine, and routinely replace 17,000 of those parts. Not after each flight, but there are certain parts that get replaced after each flight. But I didn't track the engines to find out if we took one out and what they found and what, because that was a whole nother entity that rebuilt the engines. It was Rocketdyne that rebuilt them. So
I see David Palmer's got a good question, and we've got Renato Bolton. Thank you for finding Stay Curious and our social hour here with friends all over the world. Go ahead, Marty.
Here, David Palmer is asking, was inspecting and repairing the TPS system the most time-consuming part of returning orbiter to flight readiness?
at sometimes it was, and we did a minimum of 5 documented inspections. In other words, we had a written requirement to perform the inspection and the criteria for that inspection. But our first inspection was done on the runway, which we didn't have a lot of access. You had to stand back away from it. But we did that initial inspection, especially if we had another vehicle out at the pad. We wanted to know if there was any problems with this, post landing inspection. Then once we got inside the orbiter processing facility, then we had a documented inspection where the quality control went around and using high intensity lights and a few times magnifying glasses, but they did an up close and personal looking down in the gaps between every tile and inspecting all of the tile, the reinforced carbon and that. And then before we left the OPF, we did another documented inspection without the high intensity lights, but looking at all of the outside of the orbiter again, up close and personal. While we were working on it, we were inspecting all the time. But like I said, 5 documented inspections. Then when we were in the VAB, we did another inspection before we left the VAB, different angles, different lighting and that. Sometimes the things you may not see in the horizontal, you see in the vertical. And then out at the pad, we did another documented inspection. And by documented, we did it. And then we had to sell that inspection to the NASA's quality. So as well as the company quality, you had a NASA quality performing that inspection.
Great. Good question. Thank you for joining us. Marty, again.
Here, if I pronounced the name right, Rieto Botion. Anyway, how did they seal the landing gear bays against heat infiltration? Was the same sealant used between the tiles?
No, it was not. Around the openings like the nose landing gear, the main landing gear, the external tank doors, and even around the forward reactionary control system, those have what we call as thermal barriers, depending on where they're at on the ship. But they are different components, but like on the nose and that, they are a heat resistant cloth that has Inconel springs in them that provide side loading to that. And they're multi-layered in that. They get installed and glued into position. And then as the doors close, they compress those springs. So it's similar to the seal around your refrigerator door, but it's not a rubber and magnetic seal. It's a spring loaded heat resistant material with an emissivity coating on it to withstand the heat.
Excellent. Excellent.
And oddly enough, the guy who designed, or the person who designed the nose seal or the main landing gear seal or the external tank seal did not coordinate with each other. So they're all totally different designs.
Are they really?
Yes, they are.
Ooh.
Yep.
All right. But it worked out.
Yep, they work.
Drove the
Yep.
configuration management people crazy, probably. But
Well, and the technician, you get familiar with one, and they go back and look at it and say, "Well, this isn't the way it works up front."
we've got several other great questions coming in here. We've had a great program with Terry White, who spent over 35 years working on America's reusable spaceship, the shuttle orbiters. Go ahead, Marty, with the next one.
Okay, Mark Geiger is asking, Terry, where were you during the Challenger explosion, and did you testify before the commission at the time?
Well, second question first. No, I did not testify before the commission. They didn't ask any of the workers from the floor to go out there and testify at the commission. And where was I? Right outside the orbiter processing facility, just on the north end of the VAB. We had a very good view of the launch pad, so I would go outside. All my techs were out there already, but go out there and watching that, and we watched Challenger lift off. And then as soon as we saw that turned and I knew it was in trouble. And I used to be an aircraft crash rescue specialist in the military, so I've been involved in multiple airplane crashes. But at any rate,
Hmm.
do that, and then you saw it blow up, or we saw it blow up, and everybody turned and looked at me and said, "What do we do now?" I said, "We don't do anything." I said, "You go back inside. Don't mess with any paperwork, nothing. There will be an investigation," and it did process out of OPF1, and they will want to see everything we did, Challenger wise. So, and we'll stand by to see what upper management says we do next. And basically, a couple hours later, they said, "Send everybody home. We'll tell them when they need to come back."
Lock your doors, lock your drawers, or any of that kind of stuff?
Nope. No,
Oh,
for
really?
us, it was just don't touch any of the paperwork and that. No, no, you know, once it leaves the pad, it becomes Houston is in charge of it.
What a question! Yeah, absolutely. What question that and we don't visit the tragedy too much. We want to honor the lives of the families around and the astronauts. But did you hear a bang? Was there a sound to it?
I don't recall an
Okay.
explosion noise from
I've always
Challenge.
wondered
You
that.
could see it was obvious, but you see the booster still going out in
Right.
a way. So they had to destroy the
Right.
boosters.
One was going to Miami, other
Yeah,
was St.
yeah,
Augustine, and
yeah.
they had to blow them up.
But they were fairly high up already, so a couple minutes in
Good
flight.
insight here from a man that was there. Marty was there also watching it. So where were you, Mr. Winkle?
I was in the LCC parking lot, so not far from where Terry was.
Yeah. Did you guys know each other back then?
No,
Okay. And so you
Different worlds, different responsibilities. So yeah.
And we got another question or two here before we wrap up. A great hour with Terry White.
yeah, Space Cowboy is asking a question that Amy Collins is saying he ought to go look at the Green Book, get the information. But I'll ask the question in case you know it, Terry, which I don't think you do. How often did the APUs and fuel cells have to undergo major refurbishment? Were they switched out at any point, or were they lifetime items for each orbiter?
They were not lifetime items. I don't know the projected time period to replace things like the APUs, but we did replace APUs in the orbiter processing facility.
APUs are, for those that don't
The
know, them,
auxiliary power units. That's what provides the orbiter with power, so all their hydraulics and
electricity
that
power.
works. Yes, yes. So there are 3 APUs, and but we did replace APUs in the orbiter processing facilities because the techs really hated it. It was a very strenuous job. You have to go inside the aft, climb up on this really tight scaffolding and get up there. And the APUs are heavy, but they had to unbolt them and manhandle them down to get them down and out of the orbiter net. And one of the questions I used to get on runway, especially on night landings, is what's on fire at the base of the vertical?
right up
Yeah,
there.
yeah, because
Yeah,
the
you
auxiliary
see-
power units exhausts are up there. In the daytime, you don't see that, but at night, you see flames coming out at the base of the vertical, and everybody's going, "What's going on back there?" And I have to explain to them, those are the auxiliary power units. They're doing what they're supposed to do. They're providing orbiter to the power while it's sitting there on the ground.
Well, like many of you watching it on CNN landing and at night, and I'm going, "There's a fire there. Why isn't anybody
Yep.
tending to that up there?" And then Miles O'Brien or John Zarella said, "Hey, there's that's the exhaust from the
Auxiliary power units, yeah.
on there." So many cool things about the shuttle era, and glad that we can continue to keep the memory alive. Over 355 astronauts from around the world flew in the shuttle. The only way a astronaut from Belgium or France would ever get into orbit is something that I think is its legacy. And Marty, anything else to clean up over there? You got some.
No, it looks like we're caught up for now.
Yeah,
Okay.
as a result of the orbiter taking up astronauts from multiple countries, now 40 countries around the world have astronauts.
Yeah, and it would never have been possible to talk about it from without this beautiful bird here. That we got 3 of them that you can go see and visit, and I rarely go out there to get an autograph, Marty. That I don't say, you know what, Mark, take that 15 minutes and walk in and walk back out and see Atlantis there. I don't take it for granted that I can do that.
Yeah, and you can even
living
go see
here.
Enterprise, even though it never flew into space. It was the first one
Yep.
to be tested. So
And tell everybody where Enterprise is.
it's in New York City.
That's right. On the which aircraft
Intrepid.
carrier? Intrepid on there. So we'll put our prop away time with us and enjoy all of your comments. Great show, buddy. Appreciate you a lot.
Sure.
All right. And we're going to do more programs like this with you, with Terry and other guests here that are being lined up by one of our ace volunteers, Connie McDaniel. Hard to say who's more valuable on our volunteer team around here, but she certainly is, along with Marty Winkle, given a lot of time around here. And Terry, we got a lot of good things lined up through Shuttle Fest coming up here, and we know you'll be part of that. So we wish you well. Okay, we got Lynn said thank you, and Amy Collins is giving us some more information to look up there, and they can do just that. And Mark Geiger says thanks for your asker. One more question from Marty, for Mark Geiger.
I'm looking for it. You may want to talk. I don't see it.
I said thanks for your answer, and one more question on the shuttle is were you working on multiple shuttles at one time?
Yes. Yeah, there were times that when our schedule was really busy in that, and as a manager, I was responsible for 3 orbiters. At the time, it was only the orbiter's thermal protection system I was responsible for. But yeah, I would have Challenger, Atlantis, and Discovery responsible for them. And I might have one in the orbiter processing facility, one in the VAB, and one at the pad. So in the early days, we only had 2 orbiter processing facilities and 4 orbiters, so it was very difficult. We'd have to, if an orbiter was coming back from space and going to land, we had to get it deserviced right away. So we would have an orbiter that we're working on that we'd have to make sure it had its tires and everything on, and we would take it over to VAB and just park it on the ground floor over there. So we had an orbiter processing facility to bring the one in that had just landed and get it deserviced, and then we'd take it back out and bring the other one in and continue processing it for flight. So we were doing a constant shuffling of orbiters in the earlier days, and then NASA decided to build OPF-3.
Well, excellent. Thank you so much for participating in today's Stay Curious program. Renento Button says thank you, and I said no, thank you, and thanks to the most intelligent podcast viewers out there watching today. Look at this long list here. Marty printed it out all neat for us here to read it off there. Why don't you give a shout out in your radio voice there?
Yeah. JB Jubilee, Robert Law, Steve Jochum again, Dave Stange, Jim McDade, mostly parked. So
that's Marion. He's on Merritt Island.
Okay. Carlton Bailey, Mitch Rothman, Jesse Q, Doug Forrest, Chris Calley, again, Tom Usiak, Ophelia.
Yeah.
Okay.
Sartro, she's in France.
Okay. CT Cubing. Okay. My sister Peggy, Gary Jarrell, DKS, Amy Collins, Lynn Feather, Granny to my kids, Michael Bruno, my wife Patty, Renee to bottom.
Batillon.
Okay.
Batillon.
I don't speak French.
Well, I am French.
Mark Geiger, and of course the Space Cowboy.
Thank you. So
Thanks,
many
Marky.
new faces showing up. Our numbers are trending up constantly as Marty and I are working up to our 6th year of Stay Curious. Will be March 23rd. We figure we'll hit 1,500 episodes around April Fool's Day. And it's all because of you participating in this. People like Dave Stange and Steve Yoakams found us early, and all of you like Amy Collins and Space Cowboy and coming on board here. It's just an amazing process that makes our nonprofit very happy and an important outreach for us. But more importantly, we're keeping the shuttle era alive when we talk about it on our program here with wonderful people like Terry White and Marty Winkle, who lived it, and you can't replace that. So, uh, thank you all for watching today. Tomorrow might pick up. Go ahead, Marty.
You were going to talk current events like Artemis.
Well, yeah, we were going to. If you want more, we'll just comment a little bit about the Artemis delay. What Jared Isaacman's kind of putting things a little bit the brakes on. What's your opinion of what's going on?
He's putting the brakes on pretty heavy. Matter of fact, I was just reading an article about their shutting down the second MLP
Yes,
for
right.
that. So and
That they spent $1 billion on already. By
yeah,
the
they've
way.
already spent a lot of money on it, but they said no, they're not going to do it. They'll just use the one MLP that they have for Artemis to launch any future Artemis. So
well, it gets a lot of damage each launch every 3.5 years.
yeah,
Ha, ha, ha.
but yeah.
But we'll have more to say about the current events, Marty, and stuff going on. We're developing a couple programs that put in context Artemis versus Apollo and why the cadence is just ridiculous and it's finally been exposed. And the most shuttles you launched was 9 in 1 year, but I think you averaged about 6 a year, right? For in the wheelhouse years when it was going great. It started out to be a program that they thought they were going to do one every other day, up to 15, 20 a month. And then this guy and his crew said, "Wait a minute, this was oversold." But it still was a beautiful vehicle that changed the way we live today. You better believe it. Building that beautiful International Space Station overhead, been occupied for 25 years. And we'll talk about the space station tomorrow when you can see it. Maybe we'll do a little stargazing from the backyard, show up some pictures and catch up with some current events here tomorrow.
Yep. And the orbiters, the space shuttle, did all the things that the original designers envisioned. I know we didn't turn them around as fast as they envisioned as doing it, but they did so many more things that the original designers hadn't even thought of, and we wound up accomplishing them.
And there you go, from one of the leaders of the shuttle era. So till tomorrow, when we're gonna go out in the backyard and look around and see what we can see. I'm Mark Marquette saying, come to our museum, and I can't wait to see you again to bridge the space between us.
All right, thanks.